Okay, today we're going to talk about hemostasis. This is the second part of the second half of the hematology to and coagulation lab. What's hemostasis? Hemostasis is the process of retaining blood in the vascular system in a fluid state. In other words, the process of stopping bleeding when damage occurs to the blood vessels. Process of stop bleeding when damage occur to the blood vessels. The main functions, it has three main functions. Of hemostasis. Three main functions of hemostasis. The first one is keeping blood in a fluid state within the blood vessels. The second function of the hemostasis is stop bleeding when damage occurs to the blood vessels by forming a clot. The third is removing the clot when blood stops. So we have three functions for hemostasis: keeping blood within the fluid state, within the blood vessels. Second, stop bleeding. Third, removing the clot when blood stops. Now, what's involved? What is involved? First, the blood vessels are involved in the hemostasis. Second, platelets. Third, clotting factors. Fourth, inhibitors to clotting. And you might say, well, we need it to clot and we need to inhibit it. Yeah, we have to inhibit it. And I tell you why. Third, a process called fibrinolysis, mean removing the clot when the blood stops and everything goes to normal. These five are involved in the hemostasis. Now, when we talk about hemostasis, في عندنا two parts. It's divided in two parts. The first one is called primary hemostasis. The second one is called, yes, you guessed it, secondary hemostasis. The primary hemostasis has to do with what's involved in the primary hemostasis: blood vessels and platelets. The secondary hemostasis involves clotting factors. مثل ما بنعرف, as we know, we have the proteins in the blood. They are called clotting factors. Their jobs is to make a clot whenever a damage to the blood vessels or a cut to the blood vessels. These clotting factors are mostly protein or enzymes. They circulate in the blood factors, they circulate in the plasma in an inactive form. Only get activated when we have a cut to the blood vessels and we start bleeding. Now, let's start with the primary hemostasis, the blood vessels and platelet. If we are to draw an arm, this is your arm, and you have a damaged blood vessels, and from the blood vessels you can see we have bleeding. We have what? Bleeding. The role or the function of hemostasis is to stop bleeding through primary hemostasis and secondary hemostasis. Now, as we may well know, when the damage or a cut took place in the blood vessels, it exposed a protein that binds the blood vessel together. The protein is called collagen. And else, this collagen. Now, the first line of defense in primary hemostasis, the first line of defense in the primary hemostasis, see if you can see this. This one. The first line of defense in the primary hemostasis is blood vessels constriction. So as soon as we have a blood vessel cut, immediate blood vessel constrict to limit the blood loss. How and what and how does the blood vessel constrict? This is what happened. We have arachidonic acid is turned into thromboxane A2 by an enzyme called cyclooxygenase. This is inside the tissue of the blood vessels, inside the cells. As soon as it breaks the tissue, it leaks the arachidonic acid, cyclooxygenase from platelets. This turns into thromboxane A2, act on the blood vessels to constrict, called vasoconstrictor. Constrictor. This is the first thing. The second thing, if you can see here, we have collagen, you see, and we have a small tiny dots you may see called platelet. The collagens are very sticky. The platelet that's around the cut start adhering to the collagen around the cut. Now, as soon as the platelet start adhering, it becomes activated. It becomes what? Activated. Become platelet, become activated. What it means, it turns from a disc-like to a sphere with a spiky projection. This is called activated process. And factor 8 von Willebrand factors assist in this process, in the activation process. This becomes very sticky, and more and more and more of platelet start aggregating around those sticky platelet and form what's called platelet what? Platelet plug. Platelet plug. And it plugs the cut, and the blood ceased of flowing out. So, to wrap it up, primary hemostasis involves blood vessels and platelets. The blood vessels first constrict due to arachidonic acid that's leaked from the damaged cells, turn into thrombosis. A2 is a very powerful constrictor, vasoconstrictor. Second, the platelets start sticking to the exposed collagens, turns into activated platelet, and more platelets will aggregate and more form what's called a platelet plug. Now, as soon as, and this is finished primary hemostasis, as soon as primary hemostasis form a plug, comes within 1 minute. Within 1 minute comes the secondary hemostasis, which is involved what? Clotting factor. Involves what? Clotting factors. 12 clotting factors turns fibrinogen into fibrin clot, and permanently the blood stop bleeding. The blood vessels stop losing blood by forming fibrin clot from fibrinogen with the cooperation with the clotting factors. Clotting factors become activated, turns fibrinogen into fibrin. Now, and this will stop. Now, قلنا في عنا كمان شو عنا بعدين بيجي الانهبيتورز. Now, when we have a clot here, in order for a clot not to become widespread, is repaired, immediately we have another system called fibrolysis start eating out the clot, and the repair is done 100%, and this is hemostasis. Of course, in a nutshell, this is what hemostasis is all about. Now, in the next 3 or 4 labs, we are going to talk in details about the secondary hemostasis, how the clotted factors get together and form turning fibrinogen into fibrin clot, and what is the role of inhibitors, and what type of inhibitors, what's the name of the inhibitors, and what fibrinolysis is all about. Now, we said we have clotting factors, that each clotting factor is given a Roman numeral. And clotting factor 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, and 13. We have 2 other clotting factors. They don't have a name. One is called Fitzgerald, and the other one is called Fletcher. Now, for those of you who really don't know how to read the Roman numerals, 1 is 1, 2 is 2 lines, 3 is 3 lines. This is 5. V is 5. Now, if I put a line on the left, you have to subtract 1 from the 5. This will be 4. If you put a line to the right, you have to add 1 to the 5, will be 6. So this is 4, this is 5, this is 4, and this is a 6, and this is a dash 9. So the right 2 will be
7.
Yeah, very good, 7. Now, as you may well you see 1, 2, 3, 4, 5, 7. There's no 6. Well, the reason there is no 6 because they used to be a 6. There used to be a 6, number 6. But when they discovered this protein, they thought they have a role in the clotting process. But later on, they found out with or without this protein, the clotting will go normally. So it has no role in the clotting process. So they removed 6. Rather than giving 7 back to 6 and become a confusion, they kept 7 as 7, and 8 as 8, and 9 as 9, and 10 as 10, and without 6. So we don't have clotting factor number 6. All right, now, each of these clotting factors have a name. The first one is, as you said, 5 renogen. Second, prothrombin. Third, the 3 is tissue thromboplastin. These are 4 is the only one that's not a protein. It is calcium. It's what? Calcium. And all has name, but that's not very important to know the names. But these names are very often mentioned. That's why when I say fibrinogen, I mean for factor 1, prothrombin is factor 2, tissue thromboplastin is factor 3. And all these factors are circulating in the plasma all the time. They don't cause fibrinogen to clot or turn into fibrin. Otherwise, we will die. The reason these don't, they are in the blood and we don't clot because they are circulating in an inactive form. Only can activate it while we have a blood clot. Now, scientists in vitro were able to produce a clot from plasma by 2 pathways. This pathways and this pathways. All at tissue 3, tissue thromboplastin, all these factors are in the blood except tissue factor 3 is called tissue thromboplastin in the tissue, inside the cell, but the others are in the blood, circulating in the blood. So what happened? How do we clot? As soon as the blood is cut, here the tissue damage, the cells in the blood vessels get damaged or get broken. The tissue thromboplastin, اللي هو factor 3, is leaked to the blood. The tissue thromboplastin activate. See, this is inactivated, and this is activated. A for activated. So the tissue thromboplastin that leaked from the tissue of the damaged blood vessels activate factor 7 into activated factor 7. When the factor 7 is activated, it activates factor what? 10. By the way, this is what? 10. This is 9. This is 11. 10. 1 to the left will be 10 minus 1 is 9, which is 9. And this is 11. Yeah, if you gotta think, if this is 5, this is 2 5s. 10. Now, let's go back. How do we clot? As soon as the tissue of the blood vessel is broken, the tissue thromboplastin is leaked inside the blood, activate factor 7. Factor 7 in turn activate factor شو 10. Good. Into active. Factor 10 activate factor 5. Factor 5 activate factor 2. Factor 2 اللي هو prothrombin becomes it's called thrombin. Factor 2 turn fibrinogen into شو fibrin. Into what? Fibrin monomer. Monomer يعني fibrinogen is a long protein. Cut some of the protein, it becomes fibrin. Monomer still water soluble, it's not a clot, but factor 13 turns the fibrin monomer into fibrin polymer, which is like a clot, a clot and seal of the damaged blood vessels. So this is one way. This is one way. 3, which is only happen if we have a blood cut, because these are inside the tissue. Only is exposed when we have a blood cell damage to the tissue of the blood vessels. 3 to 7, 7 to 10, 10 to 8, 5, 5 to 2, 2 to 1. Fibrinogen is what? 1. The other pathway is by the way, here I forgot to say, we require another factors in order for to factor 7 turns into factor 7A and be activated. In addition to the tissue thromboplastin, we need calcium. We need what? Calcium. Now, the second pathways would lead from factor 12 to fibrin clot. Factor 12 is activated to factor 12A, اللي هو activated by, how does it activate it? It says surface contact. As you say, the damaged vessel قلنا when the vessel is damaged, I told you earlier, exposes collagen. Exposes what? Collagen. Collagen is a negatively charged. The collagen activate factor 12. So without the blood damaged vessels, without exposing the collagens, the factor 12 will never be activated. So as soon as the factor 12 is activated, activate factor 11. Factor 11. In addition, what activation factor 11 requires 2 other factors, اللي هي Fitzgerald and Fletcher's, the 2 blood factors, clotting factors that do not require, that do not have numbers. Now, 11 activate 9, 9 activate 8. Of course, this requires calcium and another lipid called PF3. PF3, that's not a clotting factor, that's not a protein, that's a lipid. It's called platelet phospholipid. Platelet phospholipid. So, from 9, with the presence of PF3 and calcium, after factor 9 activate factor 8, factor 8 activate 10, and so forth. So this pathway leads to fibrin clot, and this pathway leads to fibrin clot. This pathway is called intrinsic pathway, and this pathway is called extrinsic pathway. Oh, sorry. This is extrinsic, and this is intrinsic. So this pathway is called extrinsic, and this pathway is called intrinsic. Now, Today, we are going to try to get a clot using the extrinsic pathway, this pathway. We're going to take plasma. Take what? Plasma, and add to it reagent. According to this intrinsic pathways, we got to a clot. We got to a clot. Look carefully here. What do we need in order for the plasma to clot in an extrinsic pathway? We don't need factor 7. We found factor 7 where? In the plasma. We don't need factor 10. Factor 10 where? In the plasma. We don't need factor 5. Factor 5 where? In the plasma. We don't need factor 2, it's in the plasma, and we don't need, of course, everything is a plasma. What else what do we need in order to get a clot, a plasma clot, through the extrinsic pathway? We need, of course, tissue thromboplastin. Tissue thromboplastin. Tissue thromboplastin, as I said earlier, it's in the tissue. So, to add, we need to add calcium. We need what? Calcium. So we need to add tissue thromboplastin, and we need to add calcium. If we add tissue thromboplastin with calcium, we'll activate factor 7 اللي هو موجود بالبلازما. Factor 7 activated will activate 10 موجود بالبلازما, and 5, 2, and 1, and we should theoretically get you a clot. So if we have, let me get rid of this. Let me get rid of this. If we have plasma and we add to it the agent that include tissue thromboplastin plus calcium, and we should get in a few seconds a clot. This test is called PT, اللي بيسموه Prothrombin time. If you add plasma to a tube along with tissue thromboplastin and calcium, there is no reason for not clotting within 11 to 12.0 to 12.5 seconds. It should be T normal range between 11.0 to 12 seconds. Of course, from phlebotomy, you know what test we need to do. The blue test tube. The blue test tube. Now, this is what happened. If we did this test and we were able to detect a clot between 11 and 12, it couldn't be before that, it could be after that, between 11 to 12.5 seconds, that means the PT test is normal. In other words, this clotting factors, and this clotting factor, and this clotting factor, and this are normal, are not decreased. Otherwise, if, for example, this clotting factors is not normal, is decreased for some reason, is not there, we get here, from here to here we cannot get, because this is either doesn't exist for or in a short supply, we're gonna take longer time to clot. So PT tell us the status of the clotting factors in the extrinsic vessel. If the PT is high, there must be something wrong in one of these factors. Something this way. Definitely, we're not talking about tissue thromboplastin because we add the tissue thromboplastin, and we're not talking about calcium because we add the calcium. We actually add the calcium. Now, the question is, of course, I'm going to give you a point, extra point, if you answer that question is right. In the plasma, we have calcium. We have calcium. Of course, we have calcium. And we're going to measure it maybe in a couple of weeks in clinical chemistry. Why do we still have to add calcium? Of course. Yes, of course, yes, exactly. Zafura show. Very good. You guessed it. Because we use sodium citrate tube to collect blood. And sodium citrate has a sodium citrate. So, as I told you, sodium citrate, how does it work? By chelating calcium. And as soon as the blood gets in contact with sodium citrate, all the calcium in the blood will be sequestered, will be absorbed, will be chelated with sodium citrate, اللي هو anticoagulant, so won't be available for clotting. That's why, so even though we have a blue top tube, this is the blood and this is the plasma, all the calcium in this plasma here is not free to participate in the clotting process. It is bound to sodium citrate. It's bound to sodium citrate. So the calcium is bound to sodium citrate, so it's not available for the clotting process. So in order for this, one more time, to clot according to this pathway, all we have to do, take the plasma, add the calcium, add the tissue thromboplastin, and we should observe a clot in the test tube within 11 to 12 seconds. If every clotting factors here, these, not talking about these, this is has a different test called PTT. Here is normal. If the amount or the activity of X is diminished, definitely it takes longer and longer and longer to clot. It depends how deficient this factor is, or how deficient this factor is, or how deficient this factor is. So that's why. So if PT within 11 to 12 seconds, in other words, we get clot between 11 to 12 seconds, that's every clotting factor from here to here is normal. Is normal. There's no deficiency in it. Thank you. Next week, we're going to talk about the extended factor, how it's extended test called the PTT. We're going to talk about the fibrinolysis. We're going to talk about the inhibitors, and have to talk about and more. Thanks. This is the experiment. We're going to do PT. We're going to do manual PT only to show you. We're going to do manual PT only to show you whether we clot or not. Now, we have the reagent. Well, guess what's in the reagent? Yes, as I said, tissue thromboplastin in addition to calcium. And the plasma here has everything except calcium and tissue thromboplastin. So if I added tissue thromboplastin reagent Plasma, there is no reason not to clot if what I told you earlier is true. Otherwise, I wouldn't be doing you a favor. Now, according to the manual, we have to take a tube that has been sitting in at 37 degrees. We add 200 reagent first. 100 microliter of plasma. 100 microliter what? Of plasma. Now, put the plasma in a water bath for 2 minutes at 37 degrees, according to the insert of the kit. It says here at 37 degrees, 100 microliter of sample, put it for 2 minutes at 37 degrees, and add 200 microliter of reagent, and mix and look for clot, and mix and look for clot. So I'm not bringing this from my own. No, open the reagent, after mix the reagent, open it. We have now this has been 2 minutes here. We add 200 microliter of reagent and immediately look for a clot. As soon as we see clot, we have to mark the watch. I can see the clot right now. I can see the clot formed right now. I don't know if you can see it. I doubt if you can see it, but I'll show it to you very soon. A fibrin clot. It clotted around 12 degrees. You can see. I don't know if you can see. Let me show it to you in a minute. All right. Can you break one of these things? All right. See this? See the clot?
Yeah.
Looks like, I don't know, I'll tell you what it looks like.
It's real.
You can tell. This is a clot. It clotted at 12.0 second on anything between 11.0 to 12.5 is normal. So there is no reason this patient that we just draw, I'm not going to tell you the name of the patient, has a normal PT. Mean all the clotting factor in the extrinsic pathway is normal. That doesn't tell us much about the extrinsic pathway, about the other clotting factors. This we're going to do next week. Thank you very much.